Yeah. Thanks, guys. This is my first time to Kiwi PyCon, and definitely first time presenting. But it's really cool. I already feel kind of strangely connected to all of you. I'm about to share some things with you that I could never tell my wife because she doesn't care. I have to do a quick correction. Nathan's actually from Wellington City Council, who is a user of the Python software that we built for the council, and he's going to give us a bit of the perspective from the public sector on Python and its applications and potential. So just to look over what we're going to cover real quick, we'll talk about why we wanted to do a forecast. This is a spatial forecast, so the interest is actually not as much about the quantities and more about the locations of where building might take place. And then we'll talk about why as software, why did Wellington want not just a report? Then how the model works in very, very brief. That part is going to be about 5 minutes. It could be an hour. There's that much to talk about, but we'll keep it brief and try to have time for questions. So then we'll also talk a bit about how modeling and ML and generally applied statistics look a bit different in the public sector versus the private sector. And then the fun part, a tour of the stack and the lessons learned about using specific Python libraries and other tools, and a little bit about why governments need more Python. Why a forecast? I'm going to pass to Nathan from Wellington City Council. So you want to run the...
Sure. Thank you, Chris.
Yeah.
Before we get to the fun coding stuff, I'll just outline some context about what the project is, why we're doing it. So in Wellington, like in most cities, we have this thing called this district plan, which is effectively a rule book for what you can do with your property. Includes just everything like noise limits, how loud your stereo can be, whether you're allowed to farm goats, and relevant to this, what you can build, how many homes you can build, how high they can be, that sort of stuff. We had an old district plan. It was relatively conservative with what you could build. In much of our residential areas, you could build one home per property. Some areas you could do townhouses, things like that. We have to review it every 10 years, so we're doing a new one, and because of housing affordability, housing supply, little things you might have heard of, and also central government requirements, we wanted the new one to enable a lot more housing to be built. So we did this in a number of ways. There were focused increases in really strategic areas, which are really good from a planning perspective or where people really wanted to live, things like around centres, around really good public transport stops and connections. And that's the orange. So in those areas, you can build 6 stories high, quite high density for Wellington. But then we also had broad increases across the whole urban environment, which is the greeny teal colour up here, where you can pretty much now build up to 3 houses, up to 3 stories on every property, in residential property in Wellington, pretty much. And so that's a really broad thing. It encompasses the entirety of our geographic area. And then we also reduced our character protected areas. That was a really controversial one. Before, all of our inner suburbs, places like Mount Victoria, were quite strongly protected for their character values. People really want to live there. They're close to town. They're really good, nice places. Really right for development. Strategically really good because they're easy to service with infrastructure and less car dependence, things like that. So we reduced our character protected areas a lot. So we made a lot of changes effectively to enable a lot more development, which meant that we needed a forecast. Before in the old plan, because we didn't enable housing in too many different places, we kind of knew where it would go. It would go where we enabled it to go pretty much. Which was really good for infrastructure planning. So council spends hundreds of millions of dollars every year on infrastructure. It's a pretty big deal for us. We need to know what roads and pipes to renew, which ones to upgrade, which ones need to be bigger, what's the priority, what do we do first. Before, it's relatively easy. We knew it would go where it can go. Now that development can pretty much happen anywhere. It's a lot less predictable. It's pretty much open. We know where it's feasible for developers to build. We've got past projections from Statistics New Zealand, but they're all based on previous policies, not the current policies, so they're kind of less relevant now. We can no longer look at the future and go, okay, we'll just extrapolate out from the past. Where we grew in the past, we'll presume we keep on growing. because of the impact or the scale of the policy changes, we needed to be like, okay, based on this really new stuff, how can we forecast growth so that we can work out where to put infrastructure and where our priorities are. So normally, councils, we're pretty old school. We need something, we commission a report, we get a PDF, we read the executive summary, some people read the whole report, we take the key numbers, we plug them into places, and we put the report on the shelf. I didn't say that. Obviously, we don't know. Anyway, there's issues with that. Those reports get out of date, right? Like, we do a report, a few years later, new projections, something happens, we need to commission new work. Okay, let's commission a new report. So they become out of date because they're static documents, right? And they're also limited in their ability to build a deep understanding, and this one was a really big one for us. We get a report, and it was kind of like the talk yesterday about AI being like skills are about knowledge and understanding. Reports provide knowledge, and they can be quite good at that, but it's harder for a report to grant that understanding. So we wanted a model which we could own and operate. We commission it once, we pay for it. The work's going to be done to build the model. We'd like the model ourselves so that we can keep on using it. It's better value for ratepayers. We've had other jobs where we've commissioned work that's required modeling. Consultants have built a model, given us a report. A bit later, we were like, oh, can you test another scenario? Can you change an assumption? They're like, yeah, sure, show me the money. And I was like, oh, okay. And then we were beholden to the consultants. We're always giving them more money to do more stuff with the model that we paid them to build in the first place. So we get the model, better value for money, sweet. Also allows us to have some fun and dig into the model. And that allows that understanding to build when we can really dig into it and see what's happening, see what impacts are of changing some inputs and some assumptions. And then as things, they always change, the economy's not great at the moment, it'll turn around at some stage, being able to rerun the model or like test different scenarios helps us kind of plan ahead better than just getting one thing being like, yep, here's this. We can play, we can test, and we can be more ready for if things are different. And we can also, as I mentioned, update it as new data arrives. We're constantly getting new data. And so being able to update it means it retains its value and we can get good results for longer. And we also wanted a model that could produce results at a parcel level. Now, obviously, we're not naive. We don't think anyone can predict what's going to happen on particular parcels of land 8 or 9 or 10 years from now. Not going to be accurate, not going to use it at a parcel level. We're going to aggregate it up into suburbs or something which is like, okay, we'll average out unders and overs. That's more reliable, more accurate at that kind of scale. But also, maybe we want to put it into infrastructure catchments, or we want to cut it up in different ways. So getting it a model that produced parcel level outputs meant that we could aggregate it up in different ways, which would help us. So that's the boring why and what, and now I'll let the others get into the fun, juicy stuff that you probably want to hear.
Thanks, Nathan. So the final output we needed looks something like this. SA2 level, that means statistical area 2 level. It's a geographic kind of set of boundaries that's created by StatsNZ and updated every few years for the census. So that's the level at which it's still informative for infrastructure decisions, but it's also aggregated enough that the averaging across parcels is going to be useful and hopefully not too inaccurate. So we needed to be able to test scenarios at this level of granularity. But you might be able to notice, especially if you're thinking about econometrics and machine learning, if you have any experience with that, a data set trying to predict this number of observations is very small. So in some ways it made sense, and we have actually more information and more data at the parcel level that would be relevant for predicting development outcomes. So we created a model that has actually two parallel models that have two very important outputs for every single parcel in the city. So the height of the extruded polygons that you see on this map represents this sort of conditional expectation. If something were to be built on this parcel in the next 10 years, what do the parcel characteristics tell us on average we can expect for the quantity of what is built? And that's quantity of dwellings. Now the color represents, given the parcel characteristics and all of the different modeling features, what we think the likelihood of an individual parcel is to add at least one dwelling. And so that likelihood of one or more is the one piece of what becomes an aggregation and simulation step after this. And then that expected quantity is the second piece. And that's why we need to average, because just because you have an average expected quantity given characteristics of a parcel, it doesn't mean that's the amount that will be built. So if we go to your house on this map, you're probably going to look at the results and be like, no way, fair, right? But you might move, someone else might come along and have a different idea. So yeah, on average, once we aggregate, then we expect better results. So then there's that next step after where we run a bunch of simulations. We're essentially doing a repeated draw without replacement, which is done by NumPy, random number generator, numpy or rng.choice, without replacement. So that picks out in each simulation, we'll run hundreds or even thousands of simulations, which parcels actually develop in a single possible future, and then which, or the quantity of dwellings added for each of those. And then that allocates a total target across the city, and we get this spatial insight. So that's all I'm going to say right now about how the model works, and we're going to talk a little bit more about some other things, including the Python stack. So,
thanks, Chris. My background's more in the private sector, but I've been working more recently on applications in the public sector. And
this is Rhys.
Yeah, I'm Rhys, sorry. And I think it's like an interesting use case in this project, kind of like brings that to light as the differences there, and then I'm going to like go through those and then talk about the way in which we design the pipeline to respond to that. So here's like a broad overview of them. In the public sector, generally you're dealing with like smaller amounts of data, like these aren't big data applications. And like, because the effect on like the cities and everything takes a long time, then it's generally slower moving. Mm-hmm. You're looking at like batch analysis and exploring different scenarios, because it's really important that what you're doing is robust to like small changes in the future. And then the interpretability is like critical. Like it might be that you're in front of an independent panel, or like that Wellington City Council is in front of an independent panel and having to defend how they came to their conclusions. The reproducibility is not so much about like CI/CD, but more a typical academic standard. And there's this focus on like extensive exploration. And then you want a model that has like a long shelf life, because the effects of what the model is trying to capture happen over a long period of time, and they're like very consequential. And you want to like be able to use that model again and again in order to like check those effects and adjust and maybe project for another 10 years. Why did we choose Python for this work? Like, it was important to us that it was open source. We felt that like Python had a large and growing tool set that could kind of respond to the needs of this project. It also handles the complexity of public data well. And then through the flexibility of Python, all the packages and things that were available, we felt that we could get to like a very deep insight about what was going to happen in Wellington, and then use that to assist Wellington City Council in responding to an expected projection. And so here's the pipeline that we kind of built or designed. So we're starting from the raw data all the way through to the scenario-based forecast and allocation that Chris was talking about. We used data version control, DVC, a lot throughout the pipeline. We use the stage feature of that in order to get from the raw data through to the features. And at that point, we kind of switched to using DVC Live, which allows you to do experiment tracking across the rest of the pipeline, not just for the ML model. And then we use Hydrogen to like handle the configurations of parameters, as well as provide a command line interface for the model itself. And so once you have your features, the match, it's talking about the match between Auckland and Wellington. Like Auckland had a particular pattern of response to upzoning, and we're like using that to match to Wellington. And then we had this baseline model for growth, and then this econometric model and machine learning model that will be explained a little bit later. Yeah. And this all kind of like came together to like provide at this Hydrogen level onwards this model to Wellington City Council so that they could like continue to do the analysis. However, like the pipeline design isn't always how the pipeline ends up. This is the stages. This is the graph of the stages in DVC. Like there was a lot of pre-processing of the public data that we needed to do in order to get it into the form that we needed. But the point of this was like to manage that complexity, right? Like we could give this off to different people in the team in order to work on a particular aspect of that, improve the data quality, and then we wouldn't need to worry about how that was like having like drastic flow-on effects that we couldn't predict. Like we could run the elements of the pipeline that needed to be kind of adjusted as a result. And like the combination of DVC for all this pre-processing and then having like the experiment tracking, which I'll talk about a bit more later on, allowed us to like give this really strong traceability and reproducibility that we think responded really well to the public sector use case.
Yeah.
Cool. I'll pass back to Chris to go a bit more into the stack.
Yeah. DVC also saved us a ton of time in model runs because it's built on Git and it looks at a hash of your data set as well as the Python files it depends on to be generated. And it can tell if you need to run it again or not, and so it just skips a stage when you can do it, and that can save a ton of time when you're doing like heavy geoprocessing stuff. So quick stack tour. Here's a look at the dependency list. We're not going to talk in detail about most of these, but I want to pull out a couple to talk about. So I'll just give you a couple seconds to read through that. Next time I'll have different colors for the different groups after this morning's talk. So yeah, that's kind of the two things I want to, two areas I want to highlight are the GIS. Because I think GIS is a really high potential area for Python in the public sector. And then the kind of the traceability and documentation stuff that was really essential. Because I don't know, have any of you guys done statistical work in Python or in R or something like that? Yeah. Okay, did you end up, was it notebooks all the way down? No much? Did you use Git with it? Yeah? Okay, you guys are good. I mean, what often happens with academics or people who come from an analysis background and not a software development background like me, is you find Python, you learn exactly just the bare minimum you need to get your analysis done, and you go at it, and after a while you look back and you're like, which file produced that output? Which one was the input? Which file path do I need? Did I save something in a different, did I rename the folder? Like it's a mess. It can be a mess. And so we had some tools that really cleaned up that mess really well. So yeah, but first let's talk about GIS. Look, this whole software as a service thing, I am not a fan when it comes to, I mean, there's areas where it works, but when it comes to analysis, what ArcGIS is doing now is just awful. And I've told them this, their representatives, like, look, your pricing model is horrible. You have to, everything you do now, if you wanna like do street network analysis, that's a separate license. It's an add-on, and guess what? You pay per user. And it's just, we used to be able to buy the software once, and you have everything on your hard drive, and you run it locally, and it's like, and then I turn around and they're draining my credits for a few files that have been stored on their server for a couple months because I forgot about them, and it's like, guys, there's Python, right? And so meanwhile, Python is kind of slowly creeping up on the capabilities of GIS. And if you have the patience to learn something like Python as a GIS analyst, you'll find there's a lot of freedom and it's free. There's a lot of capabilities. So I think all the geoprocessing is there with tools like GeoPandas and the dependencies it's built on. And visualization, there's just so many options. Like the 3D viz you saw earlier was PyDeck, which is just a Python wrapper on DeckGL. And then this is Matplotlib, old trusty, out of the box Matplotlib. So yeah, I think there's a lot of potential for Python there, and especially for budget conscious district governments who have GIS teams. Something to think about. Okay, we're at 10 minutes. 10 minutes left. Go
okay.
For it.
I was going to go a little bit more into like how we use experiment tracking. So here you can see, like, once we got to that point of the features, there was the rest of the pipeline which we wanted to track, and we had like experts working on each of those different models that you saw in the diagram. And what experiment tracking with DVC gave us is the ability to like track all the data and the hashes of that data that was going in, all the parameters that were going in, and the coefficients that came out of the models, and also metrics on those models that we wanted to track. And I think it's quite common when you're building a model, like your best model isn't necessarily the last model you built. And what this means is that you're able to like commit that as an experiment and then go back to the one that you thought performed the best, ensuring that we delivered kind of like the max value to the counts of the analysis that we did. So
Yeah.
that's
And this is a very zoomed in view, but this was keeping track of every single input in our whole pipeline and all the outputs we were interested in. So these are outputs on the screen. And then it matched the various versions of inputs and outputs to each Git commit. So super powerful tool and a pretty easy interface. Was really grateful for it. Well model tuning. Another really awesome tool we used was this thing called HydraZen, which is a wrapper on Hydra. And it manages commits and it does auto saving of, it manages configurations based on built out of YAML files. It does kind of two main things. One, it lets your configurations be composable on the command line. So you can say, oh, for this section of config, I want this group of inputs, and for that section, I want that group of inputs, and put it together on the command line in an easy way. And then it does this traceability step where it auto-generates a folder that can be time-stamped. So we had it, the top level under outputs here is a scenario name first, and then a day stamp, and then a minute stamp for each model run. And then you could decide what outputs you want in there. You could have your log. We had a Git hash. That was a custom thing we did to connect it to our repo, so we know which version of the code made what run. And then your full config input is also saved to that folder, and any overrides you did from the defaults. So super useful, very grateful, and very easy from HydraZen to build and manipulate a command line interface. It made it trivial. I'd never done it before, and it was easy. But the flip side is it requires using a whole lot of data classes in your code, because that's kind of the way it creates these YAML structures is by reading your data class signatures, both for the class defaults and for new instances. Another one that needs a quick shout out is Loguru. If you use print lines for debugging or just for anything like that, I hear the chuckle. Just don't. Just switch. It's so easy. It's literally import and then replace your print lines. It's just that, and it gives it a real glow up. So much easier to read. Gives it a lot more context of where this thing was called from. These messages. So yeah, for the terminal, it was really a win. And I only did it halfway through the project, and I kicked myself for not doing it earlier. Yeah. So yeah, kind of just to wrap up, and then I'll give it to our user for a final perspective. The Python Spatial toolkit is really getting closer to eclipsing ArcGIS. We don't need them. We got Python. Tell your friends. Tools like DVC and HydraZen are nailing traceability for us. At least it was a really powerful combination, and they can even actually be used in the same files, or to give you two different ways to control the same steps. And then Python and open source have great potential in the public sector. And I'll hand it to Nathan for a final comment on that. Go ahead.
Cool, thank you, Chris. So to finish off on why Python was really good for a model for us as a council. So as a client, we're a team of town planners and town planning adjacent folk. We know our stuff. We're not great with coding. I love Python. I've been using it kind of for a while and growing my skills of it, but I'm not trained as a coder or anything, as a programmer. Using Python, I'm kind of self-trained. So getting a model in Python was something that we could run ourselves without specialist software, without installing lots of stuff, without having to go to an IT team and on our knees and begging for things, which is always fun. And it allows us to, as relatively untechnical folk, actually use the model to test different growth scenarios, test different inputs, to make either minor adjustments, minor tweaks to it as we want, minor upgrades potentially, or if we want to, and we get the time, really dig into the nuts and the bolts and explore things a lot further and make bigger changes later on if we want to. If it was anything else rather than Python, we probably wouldn't be able to. We'd probably be able to run it, but not much else, to be honest. getting a model that we could understand, an open source Python model that we could actually look at and understand, meant that we could really understand what's going on with the model, how it's producing things, what inputs it's relying on. And for us, that increases the transparency and understanding. It helps us to explain it to people, which is really important. We've had other models for other purposes where we've had outputs and we've used them, and people have said, oh, but how is it addressing this, or is it addressing this? And we were like, we don't actually know, because the consultant didn't tell us and we can't see the model. It's a bit black box, but trust it. With this one, we can trust it, because if people ask us things, we can either answer it or look into it and answer it. Really, really important for getting buy-in to the model. And also, like, if I left, lots of people know Python. It's used for such a broad amount of things that we're more likely to get staff, and there are other staff around the council who know Python and who would be able to pick up the model and run it. So it's more resilient to staff turnover than other models I've been involved with in the past, where someone's left, no one else has been able to run the model, everything's been bad. So yeah, it's worked out really well for us. And I think that's it. So we may have a few minutes for questions.
Have this mic. Yep. If you've got a question, I'll bring the mic to you. Please be patient, because we only have one mic for questions because of the number of speakers.
The public sector can be quite conservative. How have you found the change from by report that you can maybe send to another person for a peer review and, you know, have it all locked away, this is the gold thing, to this thing where you're going to run a thing, you're not going to send that off to another person to recheck and all the rest? Lots of flexibility, but it's a big change. How's that been?
Yeah, that's a good point. I may have been a bit blasé before about the reports, but a little bit. One of the things we've been concerned about is, like, we've got this report, it's got some final numbers in it, everyone's sweet, let's use these numbers, let's plug them into our infrastructure models, let's run with them. Those numbers are likely to change over time as we change inputs and assumptions, and so we're not going to have the, like, this is it thing that we can hand on. It is going to change, and we are going to have to reflect that in our work processes. I think it's possible. We're used to things changing, but now things might change more often. But I think we can communicate that to the other users of the data, the infrastructure teams, Wellington Water, people like that, where we're putting out the fact that we have this model, and there's a lot of people who are like, this is going to be really useful. So I think we can manage that, and I think a lot of people see the value in it around council.
Mm-hmm. Yeah.
Thanks. Thanks. Great talk. Maybe I missed that, but I mean, you had this diagram that was very complicated with pre-processing and machine learning modules, and they all connected, and they had dependencies and so forth. And of course, that calls for a workflow manager. And I guess my question is, are you using any workflow management or engines to handle that, that dependency between tasks and automate these things?
We used Poetry to manage the environment and the dependencies, the Python dependencies. But as far as orchestrating the workflow, it was just custom script in Python. Yeah. And then the Hydrozen CLI helped a lot as well, because it could tell me I could use it to tell it not to run certain things that I didn't need. And then for the data pre-processing step, which is it's about the first 60% of the project, till you get to a point where you have the right inputs, and then you can actually do the analysis, right? That was all the DVC that includes a workflow management element. So it can tell whether you need to rerun a stage or not, whether something's changed. And it keeps this proof of concept of I can actually still get from raw data right to my final pre-process. We had over 20 stages of pre-processing. And I don't need to run that every time, but I need to know it's possible, and it was really good for that. Does that answer the question, or am I missing the understanding of what a workflow manager is?
Mostly about the orchestration.
Yeah. Sure.
All right, unfortunately, we are at time now. Please thank Chris, Nathan, and Rhys.